Hey, welcome guys to the first Python lesson of 2024. Today we'll be going over recursion functions in Python. Let us begin with a simple factorial. Right, so as you can see, all we have right now is a function. It will take in one parameter called x, which is just a number. So here we pass in a number 6, right? So the first time this function is called, the x value just is 6. So as you can see, the first iteration we'd have a value of x being 6. So in line 3 we are testing, is x equal to 6? No, this condition is not met. So it will jump to this line of code here. Once it jumps to this line of code, we then have to see what happens to this line right here. Now, x is multiplied by the value of factorial x minus 1. And then after this line of code, it prints out the string x value. And then lastly, it returns x. So the only problem now is when you run this code, it logs out 2, 6, 24, 120, 720, and then it says the factorial is 720. Now the common problem students face is like, if I pass in 6 the first time, this is not true, so it's going to go to this block of code here. And how do I get 2 if I start out with 6 and I'm multiplying by something? That is a very good question. How do you actually get to 2 if this number supposedly is increasing and this thing here is contradicting it? Because no amount of multiplying 6 by anything will ever get you to 2 unless it's a fraction or a negative number. So how does this line of code exactly work, right? Because this is the thing that's stripping everybody up in recursion functions. The important thing to realize when you're working with recursion is that the first step to recursion is trying to make an infinite loop. So how does this thing actually loop itself? It starts out by defining a function and then recalling that function, right? So this thing should happen infinite amount of times. The only reason it stops at any point is because you have a block of code right here where it does not call itself. So factorial x minus 1 will forever call this function an infinite amount of times until this line of code is true, and then this is where it breaks, right? So quite simply, where does this condition come true? It comes true when x is equal to 1. So what's the closest thing to 1? In this case, 720 is very far away from 1. 120 is very far away from 1. Oh, 2 is actually the closest number you can get to 1. And because it's the closest number you get to 1, you can see that this is actually a chained function. And the way that this is calculating, it's saying x multiplied equal by x minus 1, right? And because that's just x, and this one is 6 multiplied by 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1. This is where everything breaks, right? By 1. So you can ask yourself, right, which print comes true first? As you can see, the factorial, the last line, is the thing that comes true last. So the only question is, which number is printed out first? Does it print out line 7 and then does it print out line 8? Or does it jump from line 7 all the way back to line 3 and then go about it? So the answer to this question is yes, it does jump from line 7 all the way to line 3, and it does this for each instance of the loop, right? until it gets to 2, and when it gets to 2 it doesn't need to calculate anything else because the loop breaks at this point. And that's exactly why we have the intermediate value of 2. And then after this it prints out 2 finally, and then once it does this, then it jumps back to this line here. Why does it jump back? Because remember, it still had to print out this line here. So it's kind of like lagging behind, where it does the closest thing to this breaking of the loop, if that makes sense. So recursion is very confusing. You just have to remember it's an infinite loop, and the thing closest to the breakpoint in this case is in fact 1 as far as factorials are concerned. So yeah, that's about it for the first example. Now I'll move on to example number 2, which is the Fibonacci sequence. So how does this program work? Well, I started out by making a simple program that's just a function that is called once. This function, it's going to run an infinite amount of times whenever you have Fibonacci and you call it inside of its body, The reason why I didn't want this to happen all the time is because the computer will break or snap. Well, Python will just say it will reach its maximum, but in this case it's good to set a breaking point. So if you have a recursion function, think of an infinite loop, and then you just have to make a condition so that this thing actually stops somewhere, So the way this thing works is if you start out with 2 numbers, let's say 0 and 1, it's going to add this number onto that number, and then it's going to print both of the numbers out, and it's going to add this one onto that. And that's basically the Fibonacci sequence. Let's see what this looks like. And you can see we have 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, and so on. This is Fibonacci sequence, and this is actually simpler than the previous one, because in this case we set up a condition ourselves where we want it to break. This thing doesn't need to break, we're just doing it for the sake of stopping infinity. So yeah, that's about it for the first lesson. Catch you guys next time.